Doors provide access to a building and hence constitute an important element of its facade. An ill-fitting door making loud and creaking noise, a warped door requiring repairs after every monsoon is not only an eyesore and irritant, but also proves to be uneconomical. The demand for doors is enormous due to tremendous expansion of building industry. Factory-made panel shutters of standard sizes, uniform quality have proved economical, convenient, and aesthetically pleasing. As you know, selection of timber, its seasoning, its treatment is not feasible for an individual user, also not feasible by government departments. In this film, we have attempted to show process of manufacture of factory-made panel shutters, its laboratory testing if required, its field testing which is more important for site engineers to ensure proper quality in this important element of a building.
Provision of doors has been an integral part of building activities through the ages. Doors are essential for access, privacy, and security. Their shape, sizes, design, and materials vary according to the function they perform. The choice of timber as material for doors was due to its abundant availability, easy workability, rich texture, and pleasing appearance. Traditionally, doors have been made manually by the local carpenter. The increasing demand for housing and large-scale construction of buildings led to considerable standardization in size, shape, and materials for doors. This necessitated the development of large-scale manufacture of standardized doors. Mass-produced factory-made shutters has thus become very common in recent times. The advantages of using factory-made shutters are: saves time and labor, standardization in quality, cater to ever-increasing demand of building industry, uniformity in sizes, avoids warping, and are economical. The story of factory-made shutters begins from the forest. Trees are felled when they attain maturity. For most situations, Class II timber species such as Hollock, Gammery, Champ, Deodar, etc. are used. However, where desired, Class I species such as teak, shisham, cocoa, bijasal, etc. may be used. The parts of the tree mainly used are the trunks and sturdy straight branches. Felled logs are stacked and left in the open for natural seasoning. They are later immersed in water to get rid of sap and facilitate removal of bark. The logs are then sent to the sawmill and sawn to planks of usable lengths and thicknesses. The planks are then seasoned in kilns to reduce the moisture content to the desired level. They are stacked in the chamber, allowing circulation of air. Steam required for seasoning is produced in boilers. It's passed under pressure into the closed chambers. By this process, the moisture content is reduced to about 12%. To safeguard timber from termites, preservative treatment is done after seasoning. During preservative treatment, the timber planks are impregnated with suitable chemicals. The most commonly used chemicals are copper chrome arsenic, acid cupric chromate, chromated zinc chloride, copper chrome boron, and zinc beta arsenite, etc. Only seasoned and treated timber is used for fabrication. The fabrication of a shutter involves the preparation of its various components and their assembly. These are top rails, lock rails, bottom rails, stiles, and inserts. The door component size is specified as per IS 1003 of 1977 are top rail and stiles 100 by 40 mm, lock rail 160 by 40 mm, bottom rail 250 by 40 mm. Size of inserts depends upon the design of the door. Now, let's see the fabrication and the assembling process of a factory-made door shutter. The timber pieces are cut to sizes as per specifications for various members. The surfaces are then smoothened on the planing machine. Exact thicknesses are ensured by passing the members through a thickness sizing and planing machine. The next operation is to make grooves in stiles. Grooves are cut by a chainsaw machine. There is provision to adjust the depth of the grooves. The grooves are not cut through the entire depth, but remain short by 25 millimeter of the width of stile. Next, we come to the preparation of rails. In this, the rails are shaped by a tannening machine. Grooving of stiles and rails is done to accommodate the inserts. This is done by a spindle machine. Inserts are cut to sizes. These can be of commercial or decorative ply or particle boards. The finished components are then assembled. Stiles and rails are joined together by use of synthetic resin glue of a standard make. Inserts are also fitted in during this process. The assembled door is now held tightly in a frame to ensure good bonding. During this period, holes are drilled and bamboo pins fixed. Hand planing is done to get a fine finish. The door is then passed through a sanding machine to get a smooth and uniformly finished surface. For decorative purposes, beadings or moldings are also generally fixed. The doors are now ready for transportation to the site. The testing of factory-made shutters is done in two distinct stages. Testing during manufacture and performance testing. This can be further classified into laboratory tests and field tests. It may be noted that laboratory tests need very simple equipment and they can be done in the field also. While testing during manufacture, it will be ensured that correct species of timber as per specification laid down by the user is used. Rails and stiles of well-selected, kiln-seasoned and chemically treated timber as per IS 1003 are used. Moisture content should be within 8 to 14%. Stiles and rails should be one-piece members and are joined to each other by mortise and tenon joints. Ensure that rails are not of through type but are 25 millimeters short of the width of stile. Joints are glued by good quality synthetic resin carpentry glue. Ensure that panel inserts are one-piece particle or plyboard and of thickness specified by the user. It should be checked that the door and its parts are of specified dimensions and are within the tolerance limits. Next, we come to performance testing. First, the lab tests. The main lab tests are edge loading test, slamming test, impact indentation test, shock resistance test. Randomly selected sample doors are brought to the laboratory for testing. In edge loading test, the shutter is pivot supported and loaded at the top right corner with a load of 20 kg at a time till 100 kg of loading is achieved. The 100 kg load is kept constant for half an hour. At this stage, the deflection is noted and should not be more than 5 mm. On removal of load, the residual deflection should not be more than half a millimeter. Next, we come to slamming test. The door is hinged on one of the long edges and lifted 30 degrees to the horizontal. The door is allowed to drop under its own weight on a wooden rail. general condition shall be noted after every 10 drops. There shall be no visible damage after 50 drops. The slamming test is shown now graphically. The third laboratory test is the impact indentation test. The shutter is placed on 4 supports at the corners. A steel ball weighing 450 grams is dropped from a height of 75 centimeters at 10 randomly selected points away from the edges on any of the inserts, stiles, or rails. A dial gauge is used to measure the depth of indentation. This should not be more than 0.2 millimeter. Also, there should be no cracking, tearing, or delamination. The basic procedure of this test is now shown graphically. The last lab test is the shock resistance test. A leather ball of 20 centimeter dia filled with sand weighing 5 kilograms is made to swing and hit against the door 15 times. The general condition should be checked after every 5 blows. There should be no visible damage after 15 blows. The ball should be lifted up to a height of 1.25 meters above the point of impact, which should be 200 millimeters above the bottom of the door. Next, we come to the field tests. First, check the name of the manufacturer and any other identification marks as per supply order. Conduct moisture test on rails or stiles using moisture meter. Check that it is between 8 to 14% depending upon the region of the country due to various levels of humidity. The zones and maximum allowable moisture contents are as shown on the map. For example, in some coastal regions and northeastern states falling in zone 4, the maximum permissible moisture content is 14%. Similarly, in areas of Rajasthan and Maharashtra falling in zone 1, permissible moisture content is 8%. Dimensional checks for height, width, thickness, and sizes of stiles, rails, etc. are carried out and matched with specifications. The maximum permissible tolerances for height and width are plus minus 3 millimeter and for thickness plus minus 1 millimeter. Diagonal lengths are checked for squareness of the door. For this, mark the corner reference points with the help of a steel tri-square. Measure both the diagonals. There should be no difference between the two. To check that there is no warp or unevenness in the shutters, put a steel straight edge over its surface and check for gaps all along the straight edge. Check that all joints have 2 bamboo pins each in a staggered position. Open a sample door to check that edges of panels fit in the groove, leaving an air gap of 1.5 millimeter for expansion. Beading should be provided at the junctions. Scrap the priming coat at certain locations for checking its evenness. The species of wood should also be checked at this stage. Next, we come to sampling. The number of samples which are to be tested out of a lot and the number of permissible defectives are given in the table. For example, in a lot size of 26 to 50 shutters, sample size is 5 shutters and permissible number of defectives is 0. If a shutter fails any test, then double the number should be subjected to the same test. The relevant codes of Indian standards for factory-made shutters are as shown.
You have seen, viewers, in this film the process of manufacture of factory-made panel shutters, as also tests an executive can carry out in the field to identify doors of proper quality and reject poor pieces. You also seen that these tests can be performed in the field with very simple equipment readily available. I would therefore like to emphasize that executive at site play an important role in ensuring that only good quality shutters are accepted and incorporated in buildings in our pursuit of quest for excellence.